Welcome to Offshore Renewables Unplugged. I'm your host, Benjamin Lehner, and I'm here today together with our CTO at DMEC, Simon Stark. And today it will be about offshore charging. So, Simon, what is offshore charging?
Yeah,
Charging my phone at the ship?
well, that's probably something you'll find in most ships these days. I heard those floatels, the crude vessels offshore are quite advanced these days. So I think phone charging is included there amongst other things. No, but offshore charging, yeah, I think it's just very simply put, it's a way to charge an electric vessel offshore, same as you charge your electric car, just at any gas station or electric charging station these days.
So, just from my imagination, electric car, we all know, goes into a charging spot. There is a cable. You plug the car into the cable. Offshore vessel goes into the ocean, and there is a cable floating around. Sounds like a recipe for disaster. How does the cable go to the ship, and how does that charge the ship?
Yeah, I think it's in relative. It is very intuitive that electricity and water doesn't go very well together, especially if you want to have something that connects and disconnects. But there are, of course, solutions for that as well. And the key part for offshore charging, actually, that's important, is exactly this connection process. So right now, when we talk about offshore charging and about the innovations happening there, what is really interesting for us at DMEC is especially the companies that develop these chargers, because they're not straightforward technology. Actually getting something that in a relatively automated way can connect any type of electrical infrastructure to something floating as a vessel needs a few steps in between, needs some demonstration and innovation as well. But maybe before we go into that, also nice to talk a little bit about why would you even want an offshore charger?
Okay, I have a good question. Why do you want an offshore charger?
Very nice that you're asking, Benjamin. Well, first of all, I think there is a very strong drive, of course, to reduce carbon emissions. And this does not only apply to the electricity production, but also to everything that leads to that electricity production or enables that. So if we look at the Paris Climate Agreement, there's different scopes defined there, and the electricity production for a company is only one. The supply chain, everything that comes before that also plays a role. So those emissions also need to be reduced. Right now, there is two types of ways to address actually this emission reduction. There are either vessels which work on fuels, which are emission-free, or there are electric vessels.
So that's synthetic fuels, kind of.
Exactly, yeah. And there are, of course, also combinations of the two, which is something that I think at this point is something we see most commonly.
Hybrid ships with synthetic fuels and electric charging.
Yeah, so you have e-methanol vessels, for example, which then also have a battery electric system.
But the reason is they want to reduce emissions.
Yeah.
And then you can go with the fuel way or the charging way. And the hybrid way is the common way right now.
The hybrid way is the most common way at the moment, indeed. Maybe also good to just to give a bit of a scope of the problem. If we talk about the life cycle emissions of a wind farm, of an offshore wind farm, everything that happens, everything that goes into it, do you have any idea what's the highest emission factor when it comes to an offshore wind farm?
I would say ships.
Well, not they're not actually. It is steel. Steel is the biggest emission factor right now. But ships are very much up there as well. Yeah. It's roughly 15% of the life cycle emission of a wind farm that comes from the vessels in the operation, because those vessels, they have to fuel up, they have to go there further and further offshore as well, depending on where the wind farm is. These days, they have to stay there for extended periods of time, continuously burning fuel to make sure that the onboard systems all have electricity, that the water is filtered, that the crew can charge their phones, play PlayStation, and do their work, of course, as well. So there's a lot of energy demand, which right now on ships is only supplied by the onboard generators, which is then fueled by the fuel of the vessel.
Yeah.
So replacing that, first of all, has a really big impact. The nice way about using e-fuels is that you can use systems relatively similar to what you already have. So you have some kind of engine that burns a certain type of fuel and then turns that into electricity, and the electricity is what you use on the vessel. And they have relatively high energy density. Mm-hmm. However, if you want to go to battery electric, you have a much lower energy density. Batteries are really heavy. They take up a lot of space, especially when compared to combustible fuels, to carbohydrates. And you are somewhat limited, of course, in how much weight you can put on a ship. If I want to put enough batteries on a ship to work for 4 days, 5 days, that's going to be a really big ship where I can't really take anything else anymore. Yeah. So instead, what you do is you have actually a look at what is the operational requirement, how long do I really need power, and where are periods where I could actually use time for charging as well. And that is exactly where the entire discussion about offshore chargers comes from. Finding the sweet spot of how many or how much batteries do you put on a ship to still have enough capacity for things like spare parts, crew, equipment, etc. on that vessel. And then you can have a ship that is designed typically for 16 to 19 hours of operational time in a day, and then a couple of hours of charging, typically 5 to 6 hours of charging.
Okay, so I understand how it works, but maybe for some of our listeners, it might also be nice to know, why do we actually need to go with the ship? I mean, everybody understands you need to install it somehow, but why do we need to put all these things like crew, like replacement parts? What do we need to do, and why do we need to go offshore actually? And why do we need electrified vessels then for that?
Yeah, very good point. For offshore wind farms, there is typically 2 types of vessels that are needed. So we're not just talking about one boat that is going there sometimes to do something. There's 2 types of vessels where every wind farm typically has a dedicated SOV, support operation vessel, and 1 or 2 CTVs, crew transfer vessels. So an SOV is kind of like the big workshop of an offshore wind farm. So the same way that for a power plant onshore, you have a machine shop behind it to do turbine maintenance, to fix pipes, to fix electrical systems, etc. These SOVs go out there, they have all the equipment on board. Things are typically prepared, of course, very far on land to just only do the very last steps offshore. But those SOVs, they do all the maintenance routines. Mm-hmm. So you have something, for example, 100 turbines in a 1 gigawatt or in a 1.5 gigawatt wind farm. And all of these turbines need to be maintained once a year, twice a year, depending on the type of operations you're doing, also depending on how old they are, of course. And actually doing all of that just takes time. So those SOVs are typically out there for relatively extended periods of time. And the CTVs at the same time, the crew transfer vessels, they make sure that the crew that is operating offshore doesn't have to stay there for the entire operation. Typically there's something like 3-week shifts, and every 3 weeks there's a crew transfer vessel coming in, basically like a really speedy little boat, bringing in new personnel, taking off old personnel. And because you have quite a lot of people on that SOV and you don't replace them all at the same time, those CTVs go relatively regularly back and forth as well.
And for having batteries in or electrified ships with batteries, we talk about both. So both
exactly
potentially have the capacity to become charged via batteries or
exactly.
Batteries.
Yeah. So there are already concepts and designs. In some cases, also already vessels built for both of these types of vessels. The reason that those work particularly well is because you can actually operate them while the wind farm is up and running as well. Of course, there's a lot of other things throughout the wind farm lifetime where you need boats and personnel on site as well. But this is, for example, during the installation where you don't have infrastructure there yet in some cases. You don't have a substation yet, you don't have a grid connection, etc. You don't have energy on site. So there, also vessel operators are looking at reducing carbon emissions, but then mostly through synthetic fuels. And maybe one more thing, because we talked about that earlier, the switch or the consideration on either going for synthetic fuels or for battery systems. There's, of course, this trade-off in weight I talked about, but there's also a cost consideration.
Yeah.
Synthetic fuels are nearly all derived from hydrogen. And hydrogen, especially green hydrogen right now, is relatively expensive to produce. Turning that into synthetic fuel, again, is a process step that takes time, takes energy as well. So that makes it more expensive. So right now, the electric vessels are the more cost-effective option, looking at prices for batteries, which are dropping really rapidly. And at the same time, the synthetic fuel prices, which are still relatively high.
Okay. So coming back to then offshore charging, I mean, we said it's a cost factor that you go electric, but also then you want to be able, or you might even need to charge the ship offshore. So do you then use the electricity from the wind farm, I guess? Or how does that work?
Yeah, that's a very good point. The wind farms themselves, of course, produce electricity, but they're also connected to the grid. So in principle, there is electricity going both ways. Also from the substation, which is connecting to shore, there's power coming also back to the wind farm. So you could charge vessels offshore as well if there is no production from the wind turbines themselves. One important point to note here is that the wind turbines, quite often then are in a maintenance phase as well. So while you're around there with the boats, they have to be shut down anyway if you get really close to them.
Not the entire wind park, or only
the specific wind turbine. But also those can be maintenance periods where some of the wind turbines are shut down anyway. So it's really important there to have both of these options to also charge with the power that comes from shore. Because of course it's also something that's critical for the safe operation of a vessel. Running out of battery in your electric car on the highway is annoying. You might have to get towed. Doing that so on a vessel in a wind farm is not an option, because you really need to be able to maneuver the ship, of course, still. So that is going both ways. But I think this is also addressing. We've talked a little bit about some of the aspects that are important to this development. It's one of the aspects which is really important there, which is regulation.
Is it allowed currently to charge a vessel from your wind park?
I would not go as far as to say whether it's allowed or not. It is definitely a challenge, and I think there's ways around that challenge. Right now, there is no clear regulation in place
for the Netherlands now, or
exactly
Europe,
for the Netherlands. At least for all the countries, actually Europe that I'm aware of, there is no direct way to purchase electricity offshore, because the question is, the wind farm is built with a permit to connect to the grid and feed into the grid. So taking extra electricity out of that is something that is not yet regulated. So there's legislature that is still needed in order to enable that, actually, to make clear what is the price that you buy electricity for if you are a vessel operator. And how does it even work? Who's in charge of that, selling you that electricity, etc. It's one of these technicalities that will have to be sorted out with time as this concept would get rolled out.
And thinking about or talking about things which need to get sorted out, I still hold you accountable for the question of how does this work? I mean, my ship is floating. Is there a cable floating and then magnetically attaching, or how do I get these two together?
Yeah, that's exactly what a lot of innovators are looking at the moment. How can this be done safely, most importantly, and also efficiently, of course. So,
what are some concepts there?
Yeah,
just very visual.
There are two main concepts actually that you can differentiate at the moment. One is chargers which are deployed from a platform. So this is either the kind of like the landing platform. You've got the transition piece at a wind turbine, then like a little bit of a platform around it as well. You have some cranes on there. Sometimes you could put a charger on there as well. It's kind of like hanging down. You could do the same as at the substation, which is like a big platform next to the wind farm to transform the electricity to transport it to shore. And so those are kind of like hanging systems.
Cable comes from the top, ship is below, cable plugs in.
Exactly. That's a very simplified way of looking at it. And the other one are charging buoys. So buoys which are deployed somewhere in the sea, the ship approaches it, fishes something out of the water, pulls it on deck and attaches it then. And the key goal here for all of those developers is to make these connection processes especially as safe as possible, to avoid any risk of damaging the infrastructure, so the wind turbine or the substation, but also, of course, to avoid any risk for personnel. So it's very often seen as a process that should go hands-free. So like fully automatic, you really approach with your vessel. You same as a transfer vessel does. You kind of like go against the wind turbine, push against the wind turbine, lower the system. It lands on your deck. There's maybe some kind of basket that catches this connector, and then it connects automatically, having some kind of mechanism where it really slides into the one position that it can have. And then afterwards, also really important, of course, you don't want to stay too close to any infrastructure offshore longer than necessary, because you could always have influences like waves and wind that move your boat around, and you just want to be safely away from everything. So afterwards, you move 100, 150 meters away, kind of like roll out the cable, a bit like for your vacuum at home, if you still have one of these old school vacuums.
We have a robot by now.
Oh, fair enough. Not like your vacuum at home. But then you just roll out the cable. I
can still remember it
somewhere.
Though.
Yeah, stories from the 90s. Yeah.
Okay, no, I get it. Coming back to a bit also the car story. So you said, if I still have this picture in my mind, then now this car is automatically connecting to the electrical infrastructure. But how high is the charging capacity? I know we always look for a fast charger with the car, of course, because you want to keep going and you want to be charging in half an hour. So first of all, how big is the charging capacity or the planned charging capacity? And then how long does the ship then or the vessel then need to be there to be fully charged or 80% charged or whatever you do then?
Yeah, no, that's a very good point. The calculation, of course, always just depends on the battery size. And the different vessels, they have different battery sizes. The CTVs are smaller. They just sail there, drop off their people and charge and then go back.
Do they actually need to charge offshore?
Yes,
or can they?
They're typically designed because they are much smaller as well.
Yeah.
They transport like 12 to 20 people. So they're relatively small, and they therefore also don't have a lot of space for extra batteries. And if you're there already anyway, you have a certain transition period that you need there. So you might as well use the time for charging instead of hauling around extra batteries, of course. The SOVs, like the bigger vessels, they have much more constraint there. So just to maybe bore you with some numbers for a second, but
I like numbers.
SOV typically has battery capacity between like 25 to 30 megawatt hours, which is quite a lot more than your electric car probably has.
Yeah, it's normally about 66 kilowatt hours or something like that, 60 to 80 maybe.
Exactly, yeah. So we're roughly like a factor 1,000 below that, maybe factor 500, but in a couple of orders of magnitude.
So a fast charger for electric car would not be a fast charger for a ship anymore.
No, I think that would take you a while actually. Yeah, so we can calculate it together. Typically, an SOV charges up in 5 to 6 hours. So you have like a charging capacity of around 5 megawatt.
That is SOV, not SUV.
SOV, yes, an SOV. Charges up in 5 to 6 hours. So as I said, like around 30 megawatt hours. If you would do that within, what is it, like 150 kilowatt or 300 kilowatt charger, it would take you 100 hours to get there. So it's a long holiday. That's not good enough.
Long holiday
unfortunately,
break.
Yeah. And you've got to pay all these people on that boat for the time that they can't do anything at the same time either. So that's probably even below the idle demand of such a vessel, even to keep the showers and toilets running. One point that is really important to mention here, though, is that the maximum capacity that you can install on these chargers very much depends on how much space do you have there. You asked before about the size, and what makes those chargers really big is the fact that you need transformers. You need to bring the electricity down from the voltage that you have in the wind farm. For all the newer wind farms, it's 66 kilovolts down to 10 or 11 kilovolts. So the more power you want your charger to have, the bigger your transformers need to be as well. So there is a difference between retrofitting, where you have slightly limited capacity, and actually newly designed wind farms where you could maybe even integrate it in the design from the beginning. Then you can add a bit more capacity there as well. But this is really if you want to do it attached to the wind turbine directly. So not for the charging buoy so much.
Okay, so it sounds quite logical, but also that there's quite some technological effort still behind it. The goal is quite clear to get this 15% of lifetime emissions down. I guess you cannot reduce it to 0% because also, of course, you need to have the battery and everything in that then. I'm now curious, like we have now described the steps of the different technologies, how you can perform this and what the sizing approximately is. And also I understand the SOV stays there really for several days often,
Weeks,
or even weeks. Whereas the CTVs, which are going basically up and down in the same day. So that's the different use cases. Now I'm curious, who are the stakeholders who are involved in that as well?
Yeah, that's a really good point, because this is probably one of the things which right now is a bit of a bottleneck as well, because there are so many stakeholders that need to be on board in order to make this transition really happen. So first of all, we talk about charging infrastructure a lot today. That infrastructure needs to be part of the assets of the wind farm. So there's two options. Either you do it on the wind turbines, then you have to get the project developer involved, maybe even the OEM that designed some of the equipment that's in those wind turbines as well, to make sure that you can add this equipment there as well. Or you involve whoever owns the substation, which in some countries is also the project developers. In a lot of countries like the Netherlands, though, it's a system operator or another third party that owns all of these substations that then transport electricity back. So depending on these two scenarios, you need to have someone that is willing to house your charger. And typically for a wind farm, you would need maybe two chargers. In a lot of cases, one charger could also be enough. There's some nice studies from Scotland really looking at those details. Then things start getting a little bit more complicated, because like right now we talked about technical equipment and integrating that. Now we talk about investments, and when it gets to money, things get a little bit more tricky, because of course you need those electric vessels as well. How
much of the fleet of this SOVs and CTVs are electric or hybrid right now?
I think so far we have maybe 2 or 3 of those vessels which are in production right now, which are hybrid or electric.
So there's none operating right now because we also don't have the chargers yet.
Exactly, and this is kind of like the chicken and egg problem. Building those chargers into your wind farm only makes sense if you can also get those vessels to be electric and be able to use those. Now there's kind of like this transition phase where some offshore vessel companies are now building hybrid vessels, which then are also charger ready. So you can also connect them to a charger in the future. So that could be a good transition period. But basically what it means is a wind farm operator, they have a contract with a vessel operator renting those vessels, typically for the time of a wind farm, lifetime of a wind farm, sometimes for limited periods, maybe for 10, 15 years, even though the wind farm is there for 20, 30 years.
It's basically a leasing contract.
Exactly, it's a leasing contract. So they somehow have to convince the vessel operator to build a vessel which will be initially more expensive for them, and in order for them to then use it. So it is really something that will happen if the wind farm operators are willing to pay a premium for these vessels, because of course there's a little bit of an uncertainty as well about the long-term use of those vessels. If you have a 10-year contract, maybe after 10 years, everyone realizes we're not going to do this anymore. That's a bit of a risk for the vessel operators. So there needs to be some certainty, which can come from tender requirements, for example, from the government, or which can also really come from wind farm operators grouping together and making a commitment together to say we want to fully electrify, and then kind of like pulling the industry with them.
Are there from governments, like we know about this non-price criteria, which are of course important for circularity and for nature-inclusive designs? Is there anything in that direction as well to reduce the carbon footprint via electric vessels? Are these already out there? Have these been tendered in that way? Or
yeah, interestingly enough, in the most recent tender in the Netherlands as well, it was included. It was not included specifically, but through a number of criteria where it was mentioned as one of the options to score certain points. So there are sustainability and carbon reduction points where this can play a role. But where there might be other low-hanging fruit of other ways to reduce emissions that might be pursued earlier. But there are also requirements, for example, on using additional electricity from onshore. Because right now, a lot of wind farms are under pressure as well, because wholesale market prices are not what people hope they would be for electricity. So actually, the goal is to make electricity more expensive again by increasing demand and therefore reducing periods of really low prices. So those vessels, of course, we talked a lot about how they charge offshore, but they would also charge onshore. So there they can score extra points as well by actually using onshore electricity. And it also has been included in tenders in Norway as well. So there are quite a lot of first policy push, but there is not something like a full commitment from any government yet to say like we only allow electric vessels.
And we're having now 2026. Since beginning of this decade, we had three major crises reflecting in oil and gas. So from the COVID to the Ukraine to the Iranian crisis now. How does that affect the push, especially this latest crisis, on things like offshore charging? Do you see renewed interests now that oil prices are high and gas prices are high, or is it something which we need longer to penetrate through this market, or will it actually be cheaper soon than sailing on conventional fossil fuels?
Yeah, that's a very good point. I think it's in an industry like the offshore wind industry, sometimes a bit hard to gauge because we talk about like really big investments here. Talk about the vessels, which there first of all has to be a commitment to build them. Then there's a design phase. Then there's a construction phase, and until they're in operation, you're like 5 years further. So that it does take a while. But maybe it is coincidentally, maybe it's not. Since 2023, roughly, we've seen a lot of momentum in this sector. So we've seen a number of demonstrations happening all across Europe. We have seen some commitments where really big shipping companies have stepped into the offshore charging sector, developing their own solutions, and also grouping up with wind farm operators, with cable manufacturers for demonstration projects, really testing these things. I think something that could be a really interesting secondary push for this type of technology is that once you have offshore chargers in those wind farms, there are actually a lot of stakeholders that are interested in the opportunity to use them as well. So the decarbonization effects could go further than only the offshore wind farms. For example, in the Netherlands, there is a very strong push to replace some emergency towing vessels with electric vessels instead. So the government has a fleet of vessels which, whenever there's a big storm, go out into the North Sea, depending on where the storm's coming from, to be positioned strategically around certain infrastructures and be able to help vessels which get into trouble, maybe get any damage to their power systems, their rudders, their engines, etc., and can then keep them away from sandbanks, from infrastructure, etc. The Dutch government now is committed to make those electric, but because they have to be all over the North Sea at different locations, they need to have access to a lot of chargers. Building them just for themselves is really inefficient. Yeah. So having offshore wind farms could be, as like a charging station to go to, could be a really good driver there to decarbonize there as well.
So it could be either that the government supports the building of those, or that they become a customer of those, and you have
exactly.
Just, are there other customers as well? Will we see cruise ships passing by the wind farm to charge up?
I think most cruise ships have the tendency to already go to places relatively close to shore. There is some discussions on, or there are also already pilot projects to have chargers for them really outside of those places. Also because some places simply don't allow cruise ships to come into harbors anymore.
And also don't have the charging capacity, right?
Exactly.
So that's also something we're seeing. Yeah.
So those are then, they are typically connected to shore, those chargers. So There's also another project in Denmark at the moment, at Bornholm Island, an island kind of between Sweden and Poland, confusingly enough, still part of Denmark though. And that island really wants to be an energy hub, or wants to become an energy hub. So there is discussions, or there is a project looking at using those chargers for offshore wind farms, but also for other shipping industries there. So also ferries, for example, could use those chargers potentially, and as well as other cargo vessels, for example. But I think for long distance cargo vessels, it's still a way to go fully electric, as said before, due to the energy density of batteries as well.
But at one point, there could be a business model for all of those applications with this charging infrastructures.
Yeah, no, absolutely. And I think it's really about some industry setting the first step. The offshore wind industry is positioned really well to do that. I mean, those companies very often develop renewable energy projects also from the perspective that they want to reduce their overall carbon footprint as a company. Really those energy companies becoming green energy companies. So the intrinsic motivation is high. They want to decarbonize everything they're doing, so they could be also the ones that are willing to bear additional costs. But that being said, additional costs right now is something that's quite contagious in the offshore wind industry, given the situation of the electricity market and also some other material prices. So that has to be somehow supported by the government or by other research initiatives to drive the risks and drive the costs down for these types of technologies, to then from that offshore wind industry to roll out into other sectors and be used more widely.
Nice. Anything else you want to share about offshore charging?
Well, I think one thing that is really interesting about offshore charging is really how quickly it has picked up. How between 2023 and now, so many projects and demonstrations have popped up out of the ground, and those companies seem to be doing really well as well. There's a lot of interest from different sectors, from the shipping industry as well, which is really, really nice to see. So I hope that the next couple of years we'll see a lot of movement and a lot of development there, solving some of the remaining technical challenges, also addressing, of course, the regulatory challenges that I already talked about, and finding practical ways forward there to make this really the future. Because I think everyone that has seen big offshore vessels knows how much energy they just represent, how much power there is in these vessels. Anyone that is located in harbors, such as we are, has seen vessels start off as well when they go out of the harbor and this plume of dark smoke rising out of them. So it feels in a way quite futuristic to just imagine like a relatively silent vessel just going past without any engine noise, especially vessels of this size, like 70-meter support vessel, just going by electrically. Could be the reality quite soon, and I think that's really exciting.
That is really cool. Will we see also installation vessels electrifying? Is there any talk about that, or is that just too far ahead?
I think there is a few more challenges to solve there, especially what I talked about earlier, how to get the power there.
Yeah,
that varies a little bit. Those vessels typically don't have the luxury to only be there for one wind farm. They have to operate as quick as possible to go from one project to the next, because already we have a shortage of these big vessels. And simply due to the size of them, I think it's a bit less realistic. We've seen though now vessels going for methanol and other e-fuels as well. So there's definitely a movement towards decarbonizing. Electrifying is probably fully electrifying. I think is less realistic there, at least in the near future.
But we will do already a big part. And with that, I think we have covered a lot from how we decarbonize the offshore wind sector even further with electrifying vessels, how these vessels, what kind of different vessels are there, and how these vessels actually can get electrified. It's not just via batteries, but also with synthetic fuels. And especially for the installation vessels, that this is still to stay for a while because of the extreme amount of power they need and the high amount of or the inflexibility in terms of time frames. But for operation maintenance, there can be a lot can be done. A lot has happened in the last 2-3 years. You mentioned as well. And in general, it's a very exciting time to look into offshore charging and all the possibilities there, not just for the offshore wind sector, but then also adjacent sectors where the Dutch government with rescuing vessels or rescuing ships can charge as well. and other operators of vessels which might be able to decarbonize further.
Yeah.
Thanks a lot, Simon. This was great. I learned a lot, and I hope you enjoyed this episode of Offshore Renewables Unplugged.
If you allow me one final plug there as well, if you excuse the joke. There's one project actually which we are doing right now, which I'm working on with our team at the moment, which is an accelerator project. Yeah. And that project is really exciting because there we're really trying to combine a lot of these challenges that we talked about today, of decarbonizing, at the same time dealing with when do you need power where, how do you deal with intermittencies. And that's the OASIS project. The OASIS project is an accelerator really designed for system integration innovations. So we look at battery and storage developers, we look at energy system management technologies, but also offshore charging as one of the technologies that can really help to manage power flows in a renewable energy system, that can help to integrate this energy smarter into our overall electricity system. So if you're interested to learn more about the OASIS project as well, please have a look at our website, have a look at LinkedIn, the page of the OASIS project. We have a number of accelerator calls where we are looking for companies that are interested to learn more about the offshore sector, learn more about technology de-risking, about business case development, and about sustainable design and how to make sustainability part of your business case as well. So please keep your eyes peeled for that and follow along if you are interested in learning more about that.
And it's all funded by Interreg North Sea region, which we are very grateful for their support on this. Thanks a lot, Simon.
Thank you.